All right, so today we're going to talk about Module 16.2. It's about arc length and radian measure. So what I'd love you to be able to do by the end of this video is to be able to calculate the arc length of a circle and to be able to convert between radians and degrees back and forth pretty easily. All right. So first thing, what is an arc length? So arc length is the outside of the circle here, so it's this length. It's part of the circumference of the circle. Remember how the circumference of the circle is all the way around the circle, the perimeter of the circle? So the arc length is just a part of that, or it can be just a part of that circumference. So in this case, the length of arc AB is shown here by the blue and then also by my red. All right. All right, what is the difference between arc measure and arc length? So arc measure, what we were doing before is we were saying that it's a degree measure of the arc, and that is always going to be the same as the central angle. So even if it was a smaller circle like this circle or the bigger circle, the arc measure is the same as the central angle, and it's considered a degree measure. Again, it's measuring the angle measure. Well, it's measuring the same as the central angle there. Again, doesn't depend on the size of the circle. The arc length, on the other hand, is actually measuring how long this is. So it's not necessarily going to be this. It's not going to be the same as the central angle here. And what happens is when you have a bigger circle, the arc length, of course, would be bigger. Can you imagine that if you had a bigger circle like way out here and you had that same angle measure, that of course your arc length would be bigger as well. So they're different. Arc length and arc measure are different. All right, how do you calculate arc length? Well, remember that arc length is just a fractional, it's a part of the circumference. So if you think about, well, what was the circumference of a circle? Well, that was 2 pi r, remember that? So now we just want to figure out what fraction of that circle it's going to be. So if you were given how big the arc measure was, the measure of the arc, what you could do is you could just take that and you could divide it by 360, because remember 360 degrees is how much it is if you were to go all the way around the circle. So if you just go a little bit around the circle, whatever that arc measure is, you divide that by 360 and that gives you the fraction of the circle. So then you would multiply that fraction that I have circled here, you would multiply that by the entire circumference, and then that would let you know what part of the, how big the arc length is, how long it is. The other thing that sometimes they'll give you is they'll give you the measure of the central angle, and we're just identifying it as theta. So this would be the central angle, and of course the central angle is the same as the measure of the arc, so we would do the same thing. We would take the measure of the central angle, we put that over 360, and then we just multiply by the circumference of the circle, which is 2 pi r. And again, that would give you the arc length. So again, remember the central angle and the measure of the arc are the same. All right, so let's take a look at, solving one of these, figuring out the arc length. So let's say we have this nice picture on the left. It has the radius given, and it has the central angle measure given there. So all we do is we just plug in our numbers. So theta in this case is given as 60. I'll just put 60 there. And then I'm going to multiply by 2 pi, and then whatever the radius is. So the radius is 14. So then I would just, multiply all those numbers together. Now this one says that they want us to write it in terms of pi. If you ever have those directions where they want you to write it in terms of pi, that means they want pi to still be in the answer. So what we'll do is we will multiply all the numbers together except for pi. So just kind of ignore the pi and multiply all the other numbers together. So I'm doing 360 over 60, and then I'm going to multiply it by 2, and then I'm going to multiply it by 14. Now when I do this, I get that the arc length is equal to, and I got 14 over 3. And again, what I did was I left out the pi, so then I can just bring it down right next to the 14 over 3. This is what the answer would be if we wanted to write it in terms of pi. Now, a lot of times then they'll say, hey, can you round it to, maybe the nearest tenth or something? So then we would take that answer, 14 thirds, and 14 thirds, and we would multiply it by pi just to get that decimal approximation. So arc length, and I would say that it's about, and it's rounded to the nearest tenth, so it's 14.7. So, the little squigglies there mean approximately. So you should use those whenever you've rounded your answer. Now this is just kind of what the keystrokes would look like. Not keystrokes, but what your screen would look like. So you type this in, that's what I typed in, and I left out the pi, remember? And so I got 14 thirds, and so that's why I would list my answer as 14 thirds pi. And then I just multiplied them together, and I got this, and then like I said, I rounded it to 14.7. All right, let's do another guy. So this one, tiny bit harder. It shows the red as the one that we would like to figure out. So notice something. Notice that this is the diameter of the circle. So that goes, that means that this arc here would be halfway around the whole circle. That means that that green arc would be 180 degrees, the whole thing. So then if I take away the 60 degrees that's listed here, that means that what's left is the red, and that would be 180 minus 60, so that would be 120. So that means the red arc is 120 degrees. So that's what I'm going to utilize when I'm figuring this out. And then the other thing is, so I'm going to go ahead and do that. I'm going to say 120 divided by 360 times 2 pi. And then the radius is given, well, the diameter is given as 24. So we know that the radius is just half of that. So then I would list the radius as 12. So then I'm going to put that in there as well. And then I would just multiply those together. So we do 120 divided by 360, and then times, and then we're going to multiply by 2, and then times 12. And I'm leaving out the pi again because I just want to multiply all the numbers together. So I get 8, and then I'm going to include the pi, so that would be 8 pi. So this would be the arc length in terms of pi. So I'll circle that, a little bit messy, sorry. And then it says, I need the answer to the nearest tenth. So then we would just multiply 8 times pi. So, and that's going to be approximately as well. So I would do 8 times pi. So I got about 25.1. Okay, so that's arc length again. All right. And then again, just the screen on your calculator, this is what it would look like. You're just multiplying all the numbers together, leaving out the pi, and then you'd get 8, but then you'd say, oh, you have to write it in terms of pi, so then you'd write 8 pi. And then if you wanted to round it to the nearest tenth, you go ahead and multiply 8 times pi, and you get this decimal, and then you just round it to 25.1 if they asked to round it to nearest tenth. All right, now let's switch gears to radian measure. So first of all, what is a radian? So radian is just a measure, just like feet and inches and kilometers and meters. So radian is just like that. It's just a unit of measurement. It's really helpful for trigonometry. So, that's going to be something you'll utilize a little bit more in the future. But a radian, just by definition, is the angle that's formed, the angle measure that's formed whenever the radius of the circle is exactly equal to the arc length. So you would just start right here and you go moving this direction, and you would go as long as the radius. So exactly that same length. So whatever that is, that's considered 1 radian for any particular circle. Now it turns out that that is a particular degree measure. So 1 radian does convert to approximately 57.2958 degrees, or we might say it's about 57 degrees for 1 radian, okay? Now a couple visuals, just to kind of see what a radian is. So a radian again it's about 57 degrees, and so you're moving this direction. So this would be 1 radian, kind of going around the circle. And notice again, the radius is the same as this arc length. So those two are the same lengths. Then if I did that again, then I would be, moving right along. Oh, there's 2 radians. And then I would go that same distance again. So there's 3 radians. And then if I went a little bit further, then I would get to half the circle. And half the circle is considered pi radians. You can write it out in words like capital Pi like that, or our normal symbol pi radians. So pi radians is half of the circle. It's also 180 degrees, or we say pi radians. Another visual, this would be again going around the circle. So this shows, there's 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians. And then if you were to make it all the way around to the start of the circle again, then it would be a little bit more than 6 radians. It's about 6.28 radians, or we would say 2 pi. So when you go halfway around the circle, it's pi, and then if you go all the way around the circle, it's 2 pi, which is 360 degrees. All right. Further work on this is we're going to say that 360 degrees is exactly the same as 2 pi radians, as I just mentioned. There are a couple other measurements that are kind of nice to, sort of have memorized. They'll help you in the future. So again, halfway around the circle is pi radians. Half of that would be pi halves. So pi halves is just this much. It's going 90 degrees. You could go a little bit further than pi, and you could go to 3 halves pi. 3 halves pi is also 1.5 pi. And then you could go a little bit further, and you could go to 2 pi, which again is all the way around the circle. These things on the bottom aren't crazy important, but I'll just I'll talk about them for a minute. If you started off with 360 equals 2 pi, which is definitely true, you could divide both sides by 2. And if you did, then that would get you 180 degrees is equal to pi. So those are equal to each other. The other thing you could do is you could take your 360 equals 2 pi and you could divide both sides by 4. And if you did that, then you would get 90 degrees is equal to pi over 2, which I just mentioned, was a nice measurement to have memorized. And then you could start with 360 equals 2 pi, and you could divide both sides by 360. And if you did that, you would say that 1 degree is equal to pi over 180. The other thing you could do is you could start off with 360 degrees equals 2 pi, and you could divide both sides by 2 pi. And if you did that, on the right-hand side, you would get rid of the 2 pi, and you'd be left with just a 1. So it'd be 1 radian. is equal to 180 over pi, and that's actually degrees. So this would actually be degrees. Okay? Well, now let's get into some conversions, going back and forth between degrees and radians. It's really simple. If you want to go back and forth, and you're going from degrees to radians, what you can do is you can just multiply by pi over 180. I'm going to say pi over 180 degrees would work great. If you want to go from radians and you want to go to degrees, so from radians to degrees, then you just multiply by 180 degrees over pi, and that will do the trick. So let's look at some examples. And again, because 180 over pi, those are identical, you're really just multiplying by 1. That's what you're doing. All right, so let's convert. So let's say we have 45 degrees, and we're like, hey, I'd love to change this thing to radians. Well, you got to multiply by something. You got to multiply by 180 over pi, or you got to multiply by pi over 180. Which is it? So I'll tell you how I remember it. I want to change this to radians, so I really don't want to have degrees anymore in my answer. So then I always think, what's going to cancel out the degrees? Is it going to be 180 degrees over pi? Is that going to do it? Is that going to get rid of the degrees? No, because if I multiply these together, that's going to just be a bigger number, and it's still going to be degrees on the top, and it's not going to get rid of the degrees at all. So that's not going to be the thing to multiply by. But if I multiply by pi over 180 degrees, look at that. The degrees will actually cancel out. So 45 will actually go into 180 4 times, and it cancels out the degrees as well. So then I multiply straight across, and that would be pi over 4. So that goes in 4 times, right? So 180 divided by 45, yep. So this would be pi fourths, and this is radians. So pi fourths radians. All right, now let's see how we convert going the other direction. So if we have pi twelfths radians, then we would multiply and we say, okay, I want to have degrees in my answer. So if I want to have degrees in my answer, that's going to be the degrees would be on the top. And I actually want to get rid of the pi if it happens to have a pi in there. So I'm going to multiply by 180 over pi. And this works out great. So I can cancel out the pi's, and then I can reduce this a little bit. So let's see, does 180 divide into 12 evenly? Ah, it does. So we could say 12 goes into 180 15 times. So then this would be 15 degrees, okay? Or if it didn't divide it evenly, what I could do is 180 divided by 12, just multiplying straight across. But either way, it's going to work out. I'm going to get 15 degrees in this case. All right, does that make sense? That's how you can remember, which one to multiply by, just whatever thing you need to have canceled out. All right, and I think that'll do it for us today. This is, if 2020 was a slide, ouch. Have a great day today.